I'm going to do a one sample z-test by hand and then with the calculator. This is an interesting problem. I'll explain why after we go through it. Let's see what it says. It says that the cost of a daily newspaper varies from city to city. However, the variation among prices remains steady with a standard deviation of 20 cents. A study was done to test the claim that the mean cost of a daily newspaper is $1. 12 different newspapers yield a mean cost of 95 cents with a standard deviation of 18 cents. Do the data support the claim at the 1% level? Well, what's interesting about this problem is that we have a small sample, 12. Normally means we do a t-test, but unusually we are given a population standard deviation. And what your book says is that if you have a population standard deviation, you ignore the sample standard deviation. You use the population standard deviation and you do a z-test. Okay? So here's how we begin. We say, we start with the claim. And the claim is that the mean cost of a daily newspaper is $1. That's pretty easy to express. Mu is equal to $1. Then, of course, that's the null hypothesis because it's got an equal sign in it. The alternate hypothesis is mu is not equal to $1. First thing done. Second thing, the test statistic. Okay, the test statistic for one sample z-test is x bar minus mu divided by sigma over the square root of n. In this case, we have 95 cents minus $1 divided by 20 cents divided by the square root of 12. And I'll do that with the calculator. Make sure that I show you how to get these parentheses and such right. Here's what you're supposed to do. We've got, let me see, am I on? There we go. Let's turn this off. Point, a parenthesis, so yeah, 0.95 minus 1 unparen division 0.2 divided by second square root 12 paren. Now, let me show that to you so you see it quite clearly. This is important. I know that this is how you make mistakes, is because you're not used to using this calculator. We have to calculate the numerator and the denominator separately. Okay, the numerator is 0.95 minus 1. That's what that said. The denominator is 0.2 divided by the square root of 12. Now notice that, that the argument of the square root function here has got a left parenthesis, so it's also got to have a right parenthesis. But we need a second right parenthesis to make sure that the denominator gets calculated all together. So if we've done it right, we get an answer minus 0.866, or let's call it minus 0.87. Z equal to minus 0.87. Okay. Critical value. Well, 1%, 2 tails. You got plus or minus 2.575. And the interesting one for us, obviously, is that we got minus 0.87, minus 0.87, so we fail to reject H naught. We fail to reject H naught. Okay. The rejection region is here or here. All right. What I will next state the results of the test. Okay, for the results of the test, in case you've forgotten, is we go to page 364 of our textbook, and we have this little table here. And what this little table does is it says, okay, first of all, determine whether the claim is H naught or H sub A. It is H naught. Second, fail to reject the null hypothesis. There is not enough evidence to reject the claim that the average cost of a daily newspaper is $1. I'm going to write that out because this is how you make sure that you get this stuff right. This is students find this is the hardest thing to do. There is not enough evidence to reject the claim. The claim, C-L-A-I-M, the claim that the average cost of a daily paper is $1. I don't expect you to read my writing. That's okay. That's the results of the test. Okay, the last thing we have to do is p-value. Okay, and we got a z-test. And so what we do is we go to the z-table and we find the probability corresponding to the test statistic, which is minus 0.87. Okay, here's a z-table. I'm not going to try to take the trouble of fitting it all in. Let's just look for minus 0.8. I take it on faith that what these numbers run from 0 out to 789, so the one-tailed p-value is 0.19215. That's the one-tailed p-value. However, in this particular case, we have a two-tailed test. So what we have to do is we have to double that. I'll pick it up here. 0.199215 by 2. Well, it's going to be about 38.4%, or I'll just put in here as 0.384. And it's greater than 0.01. That is consistent with our results. Okay, let's do it on the calculator. We select stat tests, z-test. Okay, we have stats. We don't have anything in the list. We don't have to do those other calculations, so we proceed. Mu naught is the null hypothesis. That's just $1. The standard deviation is 20 cents. Looks like it's already in there. X bar is 95 cents. N is 12. And this is a two-tailed test. And so we hit enter. And praise be, let me see if I can get where you can see it. There it is. We get minus 0.866 and a p-value of 0.38. So this calculated results are consistent with what we did by hand. I worked this problem already, I must confess. I forgot about doubling the one-tailed p-value because we had a two-tailed test. I got 19% when I came in here and saw the 38. I knew immediately what I'd done wrong. Okay, that's it.